How do you use prime factorization to find the GCF or LCM of two whole numbers? For example, how do you use prime factors to find the GCF and LCM of 8 and 30? In this lesson, you will learn how to find the GCF, greatest common factor, and LCM, least common multiple, of two whole numbers by using their prime factors. Remember, a prime number has only two factors, one in itself. 7's prime because 7 and 1 are its only whole number factors. The first few prime numbers are listed on your screen. Composite numbers have more than two factors. 10 is composite because it has more than two factors. When we're looking for the prime factorization of a number, we're looking for the string of prime numbers that when multiplied result in that number. So I can use a factor tree to determine this. I've listed the first few primes on the screen to help us out. 40 can be broken up into 2 times 20. 2 is prime, 20 is composite, so 20 needs to be broken up further still. 2 times 10 works, 2 is prime, 10's composite, and we break 10 up into 2 times 5. We have no more numbers, no more composite numbers to break up, so the prime factorization of 40 is 2 times 2 times 2 times 5. Remember, all composite numbers can be written as a string of prime factors. A common misunderstanding is confusing factors with multiples. If I'm looking for the factors of 25, I want to find the pairs of numbers that when multiplied together give us the product of 25. I don't want to confuse that with its multiples. Remember, when you find the prime factors for a number, each of those factors have to be prime. If I stated that the prime factors of 20 are 2 times 10, I'd be incorrect. 2 is prime, but 10 is not. It's composite. All right, so how do we find the GCF and LCM of 8 and 30 using prime factors? All right, we're going to rely on our factor tree. I'm going to find the prime factors of 8. I know that 8 can be broken down into 2 times 4. 2 is prime, and 4 is broken down into 2 times 2. I know the prime factors of 8 are 2 times 2 times 2. Now 30, when I break it down, I get 2 times 15, and I can break 15 down into 3 times 5. So the prime factors of 30 are 2 times 3 times 5. What better way to compare these two lists of prime factors than to use a Venn diagram? Remember, in a Venn diagram, the center of it is the shared factor. So I'm going to look at the first prime factor of 8. It's 2. 2 is shared by 30, so it goes in the center. The rest, and I can cross them off because I'm done. The other 2's that are prime factors of 8 are not shared by 30, so they go on the 8 only side. And the other prime factors of 30, 3 and 5, are not shared by 8, so they're in the other side. When I look straight down the center, I know that that is my greatest common factor, or the largest factor that both numbers share. When I multiply straight across, I'm finding the least common multiple. So I have 2 times 2 times 2 times 3 times 5. That gives me an LCM of 120. So what's the greatest common factor in LCM of 18 and 27? Let's do the factor trees, break those up, and we find the prime factorization for both of these numbers. We're going to take those prime factorizations and use our Venn diagram. Now 2 is not shared, so it goes in the 18 only side. 3 is shared by both 27 and 18, and so is another 3 shared by both numbers. The last 3 is 27's alone. Let's take a look down the center. We know that when we multiply these two prime factors together, we'll get the greatest common factor. 3 times 3 is 9. So the GCF of 18 and 27 is 9. When I multiply across, I'll find the LCM. 2 times 3 times 3 times 3 is 54. So the least common multiple of 18 and 27 is 54. In this lesson, you have learned how to find the GCF and LCM of two whole numbers by using their prime factors.